Okay, I'm on page 13 of your packet, so you guys need to take these notes. The first thing that I'm going to go over is inverses of logarithms. So now there's two steps to finding an inverse. One, switch x and y. We've already gone over these two steps. And two, isolate y. So in other words, get y alone. So let's look at number 4. Now the first thing that I want you to do is switch x and y. So x is equal to log of base 1/5 times 3y plus 6. Now the next step is to isolate y. So I need to get this y alone. I try and look on the the outside of the log and see if there's anything first that I can pull over to the left side. There's nothing outside the log. This 3y belongs to this log, and the plus 6, belongs to the log. So, because there's nothing else I can move to the left side, I have to deal with this log. And I know to get rid of a log, I'm going to convert from logarithms to exponential. So I can do that by circling my base, throw out my line, and catch my x. So now I'm going to have 1/5 to the x is equal to 3y plus 6. So now that I got rid of my log, this looks a lot easier. I'm going to take the 6 and bring it to the left side. I'm trying to get y alone, so I'm going to subtract 6. Sorry.
Store students, you have about 5 minutes left for lunch. Please clean your area, pick up your trash.
And then I'm going to divide by, minus 6. Sorry. And then I'm going to divide by 3 as my last step. So this 1/5, I'm going to actually make sure that I have parentheses around. And then this is going to be 1/5 to the x minus 6 all over 3 is equal to y. And you could either separate this out, both under 3, and then simplify the negative 6 over 3. But I'm fine with you all keeping it like this. Or your answer could look like this. Y is equal to 1/5 to the x over 3 minus 2. Because I would simplify the negative 6 over 3, which is negative 2. Alright. So, for example, in number 10 or number 8, before I fish, I have the 5 that doesn't belong to the log, and this plus 2 doesn't belong to the log. So I want you to subtract 2 and then divide by 5. Alright. Let's turn the page over. And I'm now on page 15, and I'm looking at logarithmic equations. So, you can solve for the exponent. Let's look at this first example. Log of n plus 9 is equal to log of 4n. Now my bases are the same. This is like an invisible 10. So that means I have two logs here. So just like when we get our bases the same, when we set our exponents equal to each other, that means that n plus 9 has to equal 4n in order for this to be true. So now if I'm solving for n, I want all the n's on one side, all the numbers on the other. So I'm going to subtract n, and then I get 9 is equal to 3n, divide by 3, so n is equal to 3. Let's look at number 12. Okay, so on number 12, sorry about that, I have these two logs equal to each other, so that means m squared plus 73 has to equal 17m plus 3. What's in my logs here? But now, so now I'm going to solve for m. I want all the m's on one side. Whenever I see this m squared, I immediately think, I'm probably going to have to factor or use the quadratic formula, because when you see m squared, you're going to get two solutions for m. So I'm going to bring everything to the left side, so my right side of the equation is equal to 0. So minus 17m, and then minus 3, minus 3. So I get m squared minus 17m plus 70 is equal to 0. Alright, so I don't have a coefficient in front of this m squared, so if I want to try and factor, I'm going to have a 70 and then a negative 17. So I'm trying to figure out two numbers that multiply to 70 and add to negative 17. Negative 7 times negative 10 will give me a positive 70. Negative 7 plus a negative 10 will give me negative 17. So that means I have m minus 7 times m minus 10 is equal to 0. If I want to figure out these two factors, I'm going to set each factor equal to 0. M minus 7 equals 0. M minus 10 equals 0. So now I can add 7, and I get m is equal to 7 as one solution. Add 10, and m is equal to 10 as the other solution.